Hello, and welcome to the Trevor Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 3.4 wireless networks. Now let's get started. Securing our wireless environment is an essential duty we must take as security administrators. With the introduction of Wi-Fi 6 and faster Wi-Fi speeds, wireless architecture is now becoming the norm for most enterprises and office environments. Because of this, we must understand and implement wireless encryption and security standards in our enterprise. Wi-Fi Protected Access 2, or WPA2, is currently the most commonly used Wi-Fi security standard, and it comes with two different modes to authenticate and encrypt our Wi-Fi enabled clients. WPA2 Personal uses pre-shared keys to authenticate to the wireless network. This deployment is typically done in homes or home networks where the passphrase is needed to access the wireless network. So this is typically what you're going to see in your home environments, maybe for a guest network in your enterprise. You're just going to have a wireless access point, and you're just going to need a simple passphrase, right, to be able to connect to that WAP or that wireless access point. WPA2 Enterprise will use credentials to access and authenticate on the wireless network. WPA2 Enterprise deployments can be integrated into our Active Directory domains or use Radius or 802.1x for credential-based authentication. The term is enterprise because this is what you're going to use in an enterprise environment, right? And then just some key things to note here. So WPA2 is going to use the counter mode cipher block chaining message authentication code protocol. Woo, that is a mouthful, right? And the CCNP is going to use AES for encryption. And then the CBC MAC provides that data integrity and authentication. WPA3 is the newer version of Wi-Fi protected access and is required for all new Wi-Fi devices. WPA3 improves on WPA2 by providing brute force protection by implementing SAE, or simultaneous authentication of equals. WPA3 will provide perfect forward secrecy and ensures client and network traffic is secure even if the Wi-Fi password is compromised. In wireless networks, there are authentication frameworks that are commonly used. EAP is the Extensible Authentication Protocol and is aptly named. EAP can be built on, and in the following few slides, we will review different EAP protocols. And then one thing that is still on the security exam objectives for some reason is PAP, a really outdated way to do password-based authentication. It relies on pre-shared keys between client and server network devices to authenticate to each other. You typically don't use this in deployments anymore. It's really outdated, right? But it's still on the exam topics, so we must talk about it. All right, let's get into some EAP authentication protocols. So EAP TLS is a certificate-based and mutual authentication protocol between clients and networks. EAP TLS relies on certificates between clients and servers to provide authentication. EAP TTLS is the same as EAP TLS with one difference. The clients only have to be, the certificates only have to be on the server side. And then EAP Fast will authenticate Wi-Fi clients using PAC, Protected Access Credentials, which an authentication server will manage on your network. Now, we decided just to put these three on the slide because they're the most common, right? And the ones I kind of want to teach you about. But in the exam, it's important that you do know EAP TLS and how it authenticates between clients and networks or servers. And if you want, take a look at this chart right here. This will go over all the different EAP frameworks and how they differ, right? So again, there's a lot to be covered with EAP, and we're just barely scratching the surface of it for the Security Plus exam. Now some more authentication protocols. So 802.1x is an authentication protocol we've discussed previously that is an essential component of network access control. And 802.1x, whether it's a wireless or wired network, supplicants that is a 802.1x term. Supplicants, like computers, phones, and printers, will send authentication requests to authenticators. These authenticators will be switches or access points. Those authenticators will then forward those requests to an 802.1x server, like the Cisco Identity Service Engine server, as an example. And then that 802.1x server will authenticate the supplicants to the network. So if we were to like flow with it, right, in this simple network diagram, this computer would be the supplicant. One of these switches, right, would be the authenticator. And they would send that authentication request from the supplicant up to that 802.1x server. And now let's go over another authentication protocol, Radius. Radius is an authentication, authorization, and accounting protocol also used for NAC, or network access control. Radius is an open standard protocol commonly used in wireless networks for authentication. With Radius, you will not encrypt the entire payload. It will only encrypt the password in a Radius packet. WPS is a simple way to set up a home wireless network. WPS will take a user through a complete setup, but it is completely insecure and can be quickly brute forced because you use a WPS pin, right, during the setup, and it has no security in mind at all. Captive portals are typically used in an open network like hotels, airports, or Starbucks, for example, right? Captive portals will make your device authenticate on the network by paying a fee or entering a free passcode or password, right? Captive portals are easily bypassed, and all traffic to the wireless access point is insecure. So if you're using a captive portal as a way to get your customers or your users onto the network, you should be using a VPN on your personal devices to have some sort of security for your data. And then some more wireless considerations. So some other things to consider when planning a wireless deployment in your network is to conduct site surveys to see how you want to install wireless access points to sustain reliability and have the most availability in your network. As cybersecurity professionals, we must always remember our guiding principle, which is the CIA triad. Anytime I talk about something that doesn't seem security related, right, I like to remind us of the A, right? It's important that we help maintain the availability of our resources in a network. So even though site surveys may fall onto like a network engineer or that wireless engineer, we must know how our Wi-Fi signals are propagated to maintain availability in our networks. So a site survey is a process of assessing a specific area to plan and optimize our wireless infrastructure. And we can use heat maps, which will display the signal strength of your Wi-Fi signals over a floor plan or a physical diagram. And this can help us with our site survey if we're doing some tests, right? Or just to show us where we have overlapping channels or strong signals. Some more wireless considerations. Wi-Fi channels are the different frequency ranges used by an access point to communicate and pass traffic between Wi-Fi enabled devices. These Wi-Fi channels will have something we call overlap. When Wi-Fi channels overlap, network degradation occurs because these frequencies step on each other and essentially jam each other, causing a denial of service. As security administrators, we must ensure there's no channel overlap in our wireless infrastructure. For the 2.4 gigahertz range, we can use these three channels to ensure there's no channel overlap. These channels being 1, 6, and 11. We must also ensure that we place our access points in the appropriate area for maximum coverage with little overlap from other access points. We must also ensure that our access points are secured and cannot be reached by the average user, so they cannot be tampered with, right? So we don't want to just put that wireless access point on a user's desk where they could trip over the wire. Typically, you install it on the ceiling, right? To get the maximum coverage. And the last thing we'll talk about We must also ensure that our access points have some basic hardening so we do not create a larger plane of attack for threat actors. Ensure your access points are part of your patch management system. Ensure the defaults are changed, and ensure encryption is used whenever possible. And always be monitoring and logging your access points as well. Well, all right, that is it for this video. Stay tuned for our next video where we'll go over domain 3.5 secure mobile solutions. Thank you for viewing.